Hi there, welcome to the RPS project. Today I'm going to be going back to a slightly old project. This one, actually it's a really old project, if you can see that very well. It is basically a preamp, a little preamp for my microphone. I've got this old little dynamic microphone. Only when I put this together I got the circuit and I built it and didn't really test it, just put it together and went, hey, that seems to work alright, sort of alright, just about, I think. But I did find that, you know, if you turned it up more than about a third, half of the way, then it didn't really seem to work very well. Didn't get very good output from this. The signal didn't seem to be very good. Sometimes it was strong and other times it would be really weak. So it's not really a very good circuit, I don't think. Or is it that the circuit has just not really been, you know, biased up properly or something? There's, you know, the circuit hasn't really been looked at. I didn't look at it in detail. So what's in this box is really just a thrown together collection of a circuit that I found that I've gone, yeah, that'll do. And actually it doesn't do really, not very well. So I decided to have a proper investigation and really find out exactly what this circuit is doing and what I'm getting out. Is it actually something usable or just a horrible mess? Who knows, eh? So yeah, let's have a look at that. So have a look at the circuit. I'm going to have a look at the original circuit and also get this on the scope so I can see what on earth I'm getting and then see if I can actually make it into a proper usable signal. That's something that's going to give me a good output. So let's start with start on the whiteboard, and then we're going to get on the workbench and we're going to have a damn good look at this thing and see if it really is worthless or useful. So here we have the original circuit. This is what I originally had that I've actually built that's in that box. 9-volt battery, couple of capacitors just for sort of smoothing out. And over this side we actually start with the microphone. And what this is, basically, even though it's drawn a little odd in this circuit, is a common base transistor amplifier. Now, from this circuit, we got biasing, input, output, and the gain is set up as a product of these two resistors, this resistor here and this resistor here. That is basically how we get the gain, but then if the gain is too high, we effectively saturate the next part of the circuit. So when it comes into here, into this base, I had a little struggle with this. I thought, how is this being biased? So effectively this is, oddly enough, being biased, that base, by this resistor and this resistor and the pot. So if I have too much gain on this first stage, it swamps out this second stage, and then the emitter follower, well, it doesn't really do much, doesn't help the circuit at all. And all of these values are just sort of a bit arbitrary, really, just like, yeah, that'll do, it sort of does something. But really, when I start to look into this, I start thinking, well, those values really don't seem to give me what I want. I mean, I need to get out here a signal, and I suppose it's a case of what do I want out of here, and I want something between sort of 2 to 3 volts, but nothing more, because mainly most inputs won't want any more than about 3 volts peak to peak. So why make it higher? Because I've only got 9 volts to play with, and I've got certain amount of headroom for signal and that, so if I overdo it then I just end up probably with a horrible mess, and that's what I think I'm getting out. So I'm now going to have a look at this on the scope as it currently is. That's the circuit in the box, and just have a look to see. Let's say I'm going to put in a 1 kilohertz signal, about 20 milliamps, so it's a really small signal, could even be smaller, you know, if you're talking about microphones and line in, then they are really small signals. So if I start with something really small, and I'm going to have a look to see what I get out and see if it's actually something worth using, if it's a usable signal or whether it's just garbage. I get the feeling we know what I'm going to see, probably garbage, but let's put it on the scope and have a look at it, see what this actual circuit does. Okay, so here we have the unit on the workbench. I've got it opened up and I've got a connector probe on the signal input that I'm putting in, 1 kilohertz, 20 millivolts, and I'm having a look at the output just before it gets to the last capacitor, that electrolytic, before it's on its output. Now I haven't got anything linked up to this. I haven't got the a speaker there, not connected that, so there's no load on this, but we'll have a look and see what it does. And I expect that when you put a load onto this, it'll really distort it, probably because I haven't really designed this circuit to go into a speaker. It's not going to drive a speaker, it's going to go into the back of the computer really, so it doesn't need to have loads of current to drive anything. But let's have a look at the scope. And here we have the scope. This is what we're getting out from the unit. This is my input. Channel 1, the red, is my input. It's on 10 millivolts per division, so we're getting nearly what we should be getting input. Some loss there, never mind. And then that's the output. And as you can see, there's some heavy clipping on there. That is turned all the way up. Let's turn that down. As you see, even when I'm turning it down, it's not. It's only when I get to about there, which is almost signal off. I've only got it about a quarter of the way turned up on the pot. Now that's 2 volts per division, so I've got about 4 volts there, which is more than what I want anyway, so it's giving me more than what I need. And when I turn it up past about a third, I start to get clipping. So there I'm not clipping, so we're just about to start clipping. So we've got 2, 4, 6, nearly 8 volts. So 7.5, between 7.5 and 8 volts there, which is a lot more than what I need. I really don't need that, so that's a bit of an issue. I'm overpowering it. So yeah, I get too much gain too quickly, and then it clips it with way too high a voltage. So basically I've got to go back and bias this whole circuit so that I get a nice clean signal like that, but never goes above about 2 to 3 volts maximum, and it doesn't start clipping when I turn it all the way up. So I can turn it all the way up and get my full voltage, and I still have a lot of signal control throughout the whole turn of the pot, whereas at the moment I don't. So let's start filling with this circuit. Okay, so this is my reworked first stage of the amplifier, which is a common base amplifier, so I get lots of gain. It is no current gain because I'm not really worried in getting lots of current gain in this. I want to increase the signal voltage, so I get a good signal output, but I don't want it too high, and that was the problem. I was getting too much gain from the original circuit in its first stage. So what I've done is I've looked at this and gone, well, what sort of voltages do I want from this? I don't really want massive amount out from here. I don't know, maybe half a volt or something like that, maybe less. I don't really know what this is going to give me initially, until I started looking at it, and well, what I've got basically is, first of all, bias. I want about 1.2 volts on here because I'm putting in 20 millivolts on the input, you know, using a function generator. So instead of the microphone, which I'm expecting to be quite small, 10 millivolts, might even be less, but I mean, could be up to 20 millivolts. So I want to see what sort of maximum sort of gain I'm going to get if I was sort of, you know, had a really good gain microphone, something that gave me a good strong signal of, say, 20 milliamps, probably smaller, but never mind. And then on here, 20 milliamps is going to sit on top of maybe half a volt, somewhere there between half a volt and 1 volt here. So 1.2 volts here, 0.7 of a volt drop across there. That's just a bit more than half a volt. And then if I lose about 4 volts, if I can bias this, so I get about 4 volts across this transistor, then I'll have about 4.5 volts here in the middle of the 9 volt rail sort of voltage. That gives me plenty of headroom to work with, so I don't end up clipping that that voltage on for this output to go on to the next stage, because after this we've got the pot and the rest of the circuit, which is, you know, common emitter with an emitter follower. But this first stage to me seemed quite important to get right, so this is what I've set it up with, using these value resistors, 22k here, 220k here. That does drop me about that 4 volts there. I've got about half a volt there, around about 1.2 volts there, so I've got nice headroom there. And when I looked at this and did a few calculations, my maths isn't particularly strong, but I worked out I was going to get somewhere in the region of about 5 times the gain. So from 20 milliamps, I'll end up with about 100 milliamps. Sorry, not milliamps, millivolts. 20 millivolts to about 100 millivolts. And that doesn't sound a lot, but 20 millivolts, 100 millivolts onto the next stage of the amplifier on the base really is plenty, because we're going to be amplifying that as well on the common emitter stage. So let's have a look at this on the breadboard and see this section actually in the working and in the flash as it is working. So let's go and have a look at that. Okay, so here we are. We have my circuit on the breadboard. Over here we have that first stage, and this is what we're going to be looking at first of all. This first stage, this common base amplifier. The rest of the circuit over there, we'll have a look at that in a bit, but start here and see what this actually gives us. Is this going to give me that sort of 5 times the amplification from that 20 milliamp? Well, let's have a look at the scope and see. Okay, so the scope is on. I should turn a function generator on, and what do we got? So let me just explain what I've got here. The channel 1 is 10 milliamps per division, and we've got a nice solid 20 millivolts. Sorry, yeah, must remember to say volts, not amps. 20 millivolts, 10 millivolts per division, and that's exactly what we got there. Very nice. Channel 2 is 50 millivolts per division, so I'll just turn on channel 2. That's 50 millivolts per division, and we got 50, 100. So yeah, I'm getting about 5 times the signal. Looks very nice. And the other thing about that is it's in phase. So let me just change. So if I take that to 10 milliamps, sorry, 10 millivolts per division, you can see we're just sort of going just off the screen because we've got 10, so that's 100 millivolts. Turn it the other way, but with 50 millivolts per division, it looks like the same signal, but it's not. It's bigger because we've got 100 millivolts from 20 millivolts, so 10 times. So that works exactly as I expected it to. So let's have a move on to the next stage. So here we have the last part of the circuit. Basically, it's a common emitter amplifier with an emitter follower. Simple sort of setup. You look at how you want to bias that for your gain. I want as much gain as I can get now from that 100 millivolts, because I know what I'm getting input now, because that's my input over here. This is where it's coming from, that previous stage, through my pot. That's acting as a volume control. So as I've got full the pot fully turned down, then basically we're at ground at this point. I can't create a bias point on the base, so it just doesn't come on. So I've killed the signal, you know. That's at ground, signal can't get through, so it just doesn't work. But as you turn that up, I allow this bias point to rise so that actually that signal can start to come through. Now I thought it's a bit odd when I tried it, because it's a case of why have I got this 10 meg here? But that's what creates the bias point on here. It's like normally you'd bias it up with a resistor divider. So I need a sort of resistor divider to come on the base, and that's formed between this pot and effectively these two resistors. But that resistor is so low it doesn't really have an effect on the bias point. I've got 10 meg here, so that 10 meg makes sure that as soon as we get a signal through, there's enough. It's at a voltage point that's high enough so that actually we start getting signal through, and it's not clipping off the bottom of the signal. and if you remove that, you've got no biasing point, so the thing just doesn't work. But anyway, as you can see, the gain is an effect of these two resistors, so that creates what I want to get out, and that's my output. And then what we're using here is an emitter follower, just to give it a bit more, I suppose, a bit more stability, a bit more control. What you put in is what you get out. Of course, this will invert the signal from my from my first stage, but that's fine. I'm not worried about that. And then this one just helps maybe give it a bit more gain, a bit more control, a bit more stability, because there's no real gain made from this particular emitter follower. You get current gain, but I'm not worried about the current gain. That's why I'm not put large resistance in here. And then the capacitor, the output capacitor, before I was using an electrolytic in here, and I found that actually didn't help. So I've removed that and put in this non-electrolytic. Maybe I should use an electrolytic, I don't know, but I've decided not to on that last part of the output, just before it gets to my signal that goes off to, well, I say goes to a speaker, but we're not going to be driving a speaker. Hopefully this will be output into a computer or something like that, so it's not really going to be driving anything, so I'm not too worried about that part there, as long as it does do the job. So anyway, let's go back to the breadboard and my scope, and we'll have a look at what I'm now getting out based from this, knowing that I'm getting 100 millivolts from my first stage. Okay, back with the scope. 20 millivolts per division, 20 millivolts for my input, and when I turn up the pot now, so I'm now looking at the output stage before that last 220 nanofarad capacitor. Yeah, you can see I've got a huge amount of gain, so I'm going to have to change the scope to deal with that. So I now got that on 200 millivolts per division on the channel 2, so I'll be able to see what that output gives me. And that is the pot turned all the way up. So yeah, that's a lot less than the 8 volts we were getting, but I'm not getting any clipping at all. So I've got 200 volts per division, 200, 2, 4, 6, 8, 10, so that's 1 volt, 2, 4, so we've got 200, 400, 500, so we've got about 1.5 volts. Actually, that's giving me about 1.5 volts, so I could actually get away with putting a bit more gain on that. I could actually look at trying to put a bit more gain on the first stage, so I could actually get more like 2 volts or between 2 and 3. So I'm actually getting less gain than I want from this, but what I am getting is a really good signal that's not really distorted. It's properly out of phase. It's properly 180 degrees out of phase. There's no distortion in there. There's no as it were lag. There's no capacitance causing any problems in there. So what I'm getting is a really good output now, that hopefully will be good for my computer. And as I can see, it's actually lower than what I expected, so I can actually build in a little bit more gain into this and still probably not distort, so I can go up to probably about somewhere between 2 to 3 volts. Maybe if I can get that so it's at 2.5 volts rather than the 1.5 volts that I've got there, then yeah, I'll have a really good output signal. Let's just put the cursors on. Gonna put it on voltage. For channel 2, and as you can see, I've been looking at this, and let's just see if I can get that properly on there. Yeah, that's 1.5 volts from 20 millivolts. So 20 millivolts to 1.5 volts, and I reckon I can get more gain out of that by increasing the first stage, the common bass amplifier. It's giving me a bit more on the initial stage, so I get a bit more on the output, and yeah, I think that'll work just perfectly. Looks brilliant. Suppose I'll have to build it now and put it on the circuit board, or put it on a strip board and make it work. So really, more work to do. So there you have it, a basic circuit really. It's not much more than a common bass transformer, a common bass amplifier, a common emitter with an emitter follower, and it does work. You know, this circuit in this box does work. It just, there's too much gain, there's clipping in that, and even though I didn't show it this time, I did have a look at this with a load on it, and once you put a load on it, you do start getting some terrible distortion because it's just overdoing it. It's too much. I mean, if you really want that much gain, then brilliant, you know, build that circuit so you get loads of gain, but I don't really need that much gain. I need a sort of between 2 and 3, so if I can aim for about 2.5 volts, with the way I biased it all up, I'd get about 1.5 volts from a 20 millivolt input. So if I work it to have a little bit more gain, or maybe on that first stage, then it gives me a bit more gain on the output, and hopefully I'll get to about that 2.5 volts, which I think will be just about right for my needs. I suppose I could rework this circuit, just change the resistors and that I want to change in here, and any capacitors that I feel I need to change. I'd also change the pot, by the way. This pot in here, can't really see it there. Yeah, it's that pot. That's a 100k pot, and it's too. I don't need that sort of. I sort of get a loss of control when you're trying to turn it up. You know, you basically, most of your amplification takes place in the first sort of half of the turn of the pot, which is way too much. So what I did is I changed it for a 10k pot and actually put a 10k resistor in parallel with it to give me basically about 5k on the pot, and that's much more progressive turn to give me a nice progression on the amplitude. Yeah, so it's a circuit that works. You just have to remember to bias it up properly so you get out what you want, because otherwise it just very easily ends up overdriving, getting too much gain, too much signal. You can end up with clipping and then distortion and other sorts of problems. But yeah, hopefully I'll get it working nicely how I want it to work. I'm not very keen on maths, but I had to do a bit of maths to make it work. So yeah, I suppose that's the lesson in biasing up properly again. You know, it's an important part of making sure a circuit works, and deciding what you actually want out of a circuit. Decide that I want a particular voltage out, and from that circuit I can get it. Spend a bit of time working on it. Anyway, if you liked this video, give me a thumbs up. If you didn't, you know what to do. Subscribe, and all comments are welcome. See you next time.